Hello guys, welcome to Placeboard to Edu and my name is Vinay Kumar Nainbatani. Today we are going to see Nodal Analysis Part 2. In this we are going to learn about Nodal Analysis with Supernode. So let's get started. See here, this is the circuit we are going to do Nodal Analysis on. And we'll just follow normal steps. So why we get Supernode, we'll see that. So what are the steps? Step 1 is, for the detailed steps you can see the previous video. Step 1 is counting the nodes 1, 2 and the reference node and taking it as reference node. So we have 2 nodes. So what are the voltages of 2 nodes? V1, V2, and this one is the reference node, right? And what is the step 2? We need to do some assumptions. Here I am going to do some assumptions like V1 is greater than 21 volts because I want the current direction to be like this. Okay, so V1 is this one, and if V1 is greater than 21, which implies V1 is greater than 0, right? So the current direction will be here, this one, and V2 is greater than 0, so we have the current directions like this, and V2 is greater than V1 because 9 volts positive is connected to V2, so I am writing the V2 is greater than V1. Okay, now the current direction is this one. So we got the current directions, but what will be the magnitude of currents? Let us see by writing the KCL at node 1. So I am writing KCL at node 1. So writing the KCL at node 1, I have, see, at node 1 there are no currents entering into the node. So current entering the node is 0, which is equals to current leaving the nodes, that is this one, this current, let it be I1, this is I2, I3, I4, I5. Okay, so 0, and the current I1 is nothing but V1 minus 21 by 4. Okay, what is I2? It is V1 by 3. And what is I3? See here, in order to get the current I3, it should be in the form like it is V1, this is V2, and there should be some resistor or something which we have to apply the Ohm's law. But here we have voltage source. For a voltage source, the current will be purely depending upon the circuit in which it is connected. But here we don't know the current exactly. So whenever we don't know a current in a certain path, that too it will be definitely the voltage source, then it is known as supernode. So whenever there is a supernode, we can't directly apply nodal analysis. So what will be the improvised step here? Improvised step will be V2 minus V1 is equals to 9 volts. This is the step which you have to consider. So whenever there is a supernode, we will directly get a nodal equation. This is one nodal equation. So we will get another nodal equation from the circuit. So here we don't need to find the current of this node. What we have to do is we can directly short that. Okay, so you should observe that after shorting, since V1 node 1 and node 2 are shorted, you should not say that V1 is equals to V2. That's a wrong statement. It is shorted for the analysis purpose. It doesn't mean that V1 is equals to V2. Understand? That you have to keep it in mind. This is just shorted such that we can get the I3. Understood? So now what is I3? I3 is nothing but I4 plus I5. So here I have I3 which is equal to I4 plus I5. Here 0 is equals to V1 minus 21 by 4 plus V1 by 3, and I3 can be written as I4 plus I5. So what is I4? I4 is nothing but V2 by 6. So I am writing here I4 as V2 by 6 and I5 is V2 by 2. Okay, V2 by 2. So solving this, we need to find the LCM of 2, 3, 4, 6. It is like 2 1s, 3, 2 2s, 2 3s, and 3. Okay, so now the LCM is 2 3 6, 6 2s are 12. So we got the LCM 12. So 4 3s are 12, and this is 3 1s 63 plus 3 4s 4v1 plus 6 2s v2 and 6 v2. If you face any difficulty in finding the LCM, I have a playlist, mathematics, basics of mathematics. You can find LCM in there. You can watch it. And then I have to simplify. So 3v1, that is 3v1 plus 4v1 will be 7v1, and 2v2 plus 6v2 will be 8v2, which is equals to 63. We have this equation. This is the nodal equation 1. Okay, this is first nodal equation, and the nodal equation from the voltage source will be the second nodal equation. So what will be the second nodal equation? That is minus v1 plus v2. v2 minus v1 is equals to 9. We have to solve them. What I will do? I will use substitution method to solve this. Substitution method. Okay. So how to use the substitution method? See here, v1 plus v2 is equals to 9. If I send this v1 that side, that is v2 is equals to 9 plus v1. So I am going to substitute this v2 in this equation. So I will get 7 v1 plus 8 into 9 plus v1 is equals to 63. 7 v1 plus 7 9s are, sorry, 9 8s are 72 plus 8 v1 is equals to 63. 7 plus 8 is 15 v1, and here 63 is minus 9. So we have v1 is equals to minus 0.9 by 15, right? Minus 9 by 15. 3 3s are 3 5s are 5 0.6. So we have v1 is equals to minus 0.6 volts. Understood? We got the v1. And what is v2? We can substitute this v1 in here such that we will get the v2. So v2 is equals to 9 plus v1, that is minus 0.6. That is nothing but 9 minus 0.6 is 8.4 volts. So we got the nodal voltages, that is v1 is equals to minus 0.06 volts and v2 is equals to 8.4 volts. v2 is equals to 8.4 volts. Okay, but here in the question I didn't mention that we have to find the small v and small I, therefore they are indicated in the circuit diagram. So what is small v? Small v is nothing but the voltage across 3 ohms, right? So the voltage across 3 ohms is nothing but v1. So we have small v is equals to capital V1, that is minus 0.06 volts. Nice. And what is I? Small I is nothing but I5, right? See here, this I5 is nothing but small I. What is this one? That is V2 by 2. Okay, what I got? V2 8.4 by 2. That is nothing but, I'm writing here, 8.4 by 2 is 4.2 amperes. In this way, we have to do the sums related to nodal analysis, which is having supernode.
Hope you guys enjoyed this video. So please like, share, comment and subscribe. If you guys didn't like this video, please let me know through comments. Thank you.